Hi, this is Alvaro Carrasco, and this is the third video on working with actors in Unison. On the previous video, we created a simple simulation of a mining site with some miners and a truck. On this video, we'll clean up that code and make it more type safe. So we'll start by examining the types of the miner behavior and the truck behavior. Here, Visual Studio generates them for us, so I can just click that, and I get the types. These are the types that were inferred by Unison, and now I'm able to specify them explicitly. So the first thing is the type of truck. It's an actor ref of na, which means it's a reference to an actor that can receive numbers. And that makes sense because that's what we're sending it. We're sending it the amount of iron that this miner has mined. Okay, next, in the process of executing its behavior, this miner actor needs to be able to log text, which is what these functions require, and it needs access to the actor ability, which is what allows it to send a message to another actor. Okay, and it returns R. But what is R? R could stand for anything, and the reason is because this actor, the behavior of this actor, never returns. Since we are using a forever, we can promise to return anything, since we never have to fulfill that promise. So to keep it simple, I like to actually just say that it's unit, but R works just as well. Okay, now let's do the same for the for the truck behavior. So the truck behavior takes a na, which is the amount that it has piled so far. It also needs the log text ability, and it also needs the actor ability, where G, we're also leaving it unspecified. But in this case, we are specifying that this truck needs to be able to receive a number. And that's how we are able to use this receive function here. Okay, now this actor ref feels a little unsafe because we could technically pass a reference to any actor that can receive a number. We would like to narrow this a bit, maybe to prevent errors or maybe to make the code a little clearer. So the way we can do that is by creating a type for the truck that wraps this actor ref. So we'll call it truck with just the one constructor that holds our actor ref for the truck. And actually it's actor ref of nat. There. So now we can update this to truck. But now we have a little problem. So we can't send to it anymore because it's no longer an actor ref. And we could unwrap the actor ref right here. But the point of this exercise is to sort of abstract a little bit the mechanics of sending with the actor system. So what we'll do is create a function in the namespace of the truck type that does this for us. So we'll call it add to pile, since that is the intent of what we're doing here. We're trying to add iron to this truck's pile of iron, and it will take an amount, the amount that we want to send, and it will take the truck itself. And it won't produce anything because this is a fire and forget type of call. We just want to send this information to the truck. Okay, and at this point, we do want to unwrap the internal actor ref of this truck. So we'll use pattern matching. And here, now that we've unwrapped the actor ref, we can just send to it. well, let's call this truck actor, and we will send the amount that was specified here. Okay, so now we should be able to, instead of calling this actor send, we should be able to just reference this function, truck add to pile. Okay, now we have some error at this point, because when we started the miner behavior, we were passing it an unwrapped actor ref, which we need to wrap. We could wrap it here, but really we do want to hide the mechanics of all this spawning as well. So a convention that we can follow is to create a start function that will initialize and spawn our any domain specific type of actors that we want to create. In this case, a truck. So when we spawn the truck here, we are giving it how full it is, but we don't need the caller to provide that information. We know that we'll always spawn a truck as empty, so we can just say that we'll produce a truck. And this code can all go in this start function. Call it truck actor. And then we will return the wrapped truck actor. And we're getting an error because in this particular case, Unison is not able to infer that this function requires the actor ability. So we'll just have to help it along. So all we need here, since all we're doing is spawning, all we need is the actor ability. We don't need the log text, and we don't need to specify these types either. So now we can use this function to spawn our truck. Start. Okay, now we want to do the same thing for the miner. We want to hide away this spawn business. So we will create a type for the miner that wraps the actor ref for the miner. And a miner, at the moment, at least, it doesn't need to receive anything. So we'll just say void for the type that it receives. That means it doesn't receive anything. And we'll create a start function for it too. But in order to start a miner, we need a reference to a truck. So we'll take that truck as a parameter. And then we'll return our fully spawned, instantiated miner. Truck. And we can copy the code right here. We'll call it the miner actor. And we will wrap it just like we did with the truck. Okay, here Unison was able to infer the correct type. To be clear, we could specify it explicitly. So this does require the same type. It just needs to be able to spawn an actor. Okay, now we can use our new start function for the miner. So we start it by providing it a truck. Okay, so this should be a little bit more type safe. It doesn't seem like a huge improvement, but it becomes more necessary as these actor systems start to grow and more references to actors are passed as parameters. Okay, next thing we'll do, since we're creating these namespaces for each of the actors that contain all the either the initialization or code that handles sending a message to the actor, we'll also namespace the behavior of the actor, just to follow sort of that convention, that organizational convention. So the minor behavior, we'll call it minor.behavior. The truck will do the same thing, truck.behavior. And we'll have to update these. Oh no, this is the minor behavior. And this is the truck behavior. And we'll update it here too. Okay. Next. Right now we have this 30 number. It represents the capacity of the truck. But maybe we want to configure that, or we don't want to use just a number here. Maybe when we start the truck, we want to define its capacity. So let's try doing that, so we can maybe spawn different trucks with different capacities. So before, when we start a truck, we didn't take anything. We just do it's just a suspended computation. But now let's say we do want to take the capacity of the truck as a parameter. So let's say capacity. This capacity needs to be accessible to the truck behavior. So we'll go to truck behavior and add the capacity here. And we need to also pass it whenever we recurse on the behavior. So capacity. Okay, now let's see what error we have. Oh, here, we need to pass that capacity. Okay, and when we start the truck, now we'll be able to specify this particular truck has a capacity of 30. Okay, something that I don't like that much here is that even though the capacity never changes in the lifespan of this truck, we're always having to pass it along every time we recurse on the behavior of this actor. We can clean this up a little bit. So inside of this behavior, we can sort of define an inner behavior that we will use for the recursion. The convention in Unison is to call this function go. And this function will only take the things that can change in the lifespan of this actor. So the thing that we want to change is the amount piled. The capacity shouldn't change. So this function will take as a parameter the amount piled, and the rest should really be the same as before, or as the outer behavior. So now we can shadow this variable. And the behavior of this inner behavior, actually we'll keep this log inside of that too. And the starting point of this inner behavior would be the amount piled. Okay, so right now we have the same thing. We just created a function that doesn't take the capacity, and we can initialize here. But now that we have this function, we don't have to call this outer truck behavior. We could just say go, because we always have access to the capacity from this scope, so we don't have to pass it along every time we recurse anymore. We can just say go here. So I like to do that because it makes it clearer what type of things change as the behavior of the truck is updated. Okay, so this to me looks a little cleaner. I think that's it for this video. On the next one, we will probably make this simulation a little bit more complex. Yeah, see you then.